All around us, right at this very moment, there's this invisible battle being fought. I mean, on bridges, on ships, on pipelines, a silent war is being waged against this absolutely relentless natural force. And the technology that forms our shield? Well, it's something we see every single day, but we probably don't really understand it. So, let's dive into this unseen world.
First things first, let's just talk about the stakes here. This number, $2.5 trillion, that is the estimated global cost of this one natural process. And that's not a one-time thing, that's every single year. To put that in perspective, we're talking about 3.4% of the world's entire GDP, just gone, wiped out by this quiet, destructive force.
And this is the enemy behind that massive price tag. It's corrosion. And look, we're not just talking about a little bit of rust on your car. No way. This is about catastrophic structural failure, industrial disasters, and just the slow, steady decay of the very infrastructure that holds up our modern world.
Okay, so for every massive problem, you hope engineering has a solution, right? Well, in this story, the hero is a specially designed shield. And it's not made of some fantasy metal or magic, it's made of something we all know. Coatings. So, what exactly are these shields? Well, this first section really gets to the heart of it. We're talking about coatings, which, yeah, you can think of them like paint, but it's paint with a much, much more important purpose.
Now you might think, okay, paint is just for making things look nice. And for the most part, you'd be right. The paint on your house, that's primarily for aesthetics. But industrial coatings, that's a whole different ballgame. These are highly engineered products. They're literally designed from the molecule up for specific protective and functional properties. They truly are paint with a purpose.
And that purpose can be a whole lot of different things. Of course, aesthetics play a part. Think of that specific Coca-Cola red or the exact safety yellow for a walkway. But coatings are also used for really specific performance requirements. And most critically, for corrosion control. That right there, that's the big one.
And this is just a perfect example of what I mean by performance. This isn't just some yellow paint slapped on stairs. No, this is a coating that has been engineered with a very specific texture to increase friction, which helps prevent slips and falls. It's a fantastic example of a coating doing a critical job that goes way beyond just its color.
All right, so now let's get a much better handle on the main adversary here. Let's really dig into that $2.5 trillion enemy, corrosion.
So what is it, really? Well, at its core, corrosion is a totally natural process. See, refined metals like steel, they're actually inherently unstable. They want to go back to their original, more stable state, which is ore, rock. So corrosion is simply the chemical reaction that lets them do that. It's basically nature trying to reclaim everything we've built. And the consequences are just incredibly severe. I mean, just look here. On the left, you've got this strong, durable, impact-resistant pipe. As it corrodes, it loses all of those essential properties. It gets weak, it loses thickness, and eventually it just can't do its job anymore. This degradation is exactly what we're fighting against.
To defeat an enemy, you have to understand it, right? So how does this whole process actually work on a chemical level? Let's peel back the next layer here and look at the fundamental science of rust.
Okay, so it all comes down to something called an electrochemical cell. And this isn't a physical thing, it's not a battery you can hold, it's a condition. It's a tiny little electrical circuit that forms right on a metal surface, and that little circuit is the engine that drives all corrosion.
And every single one of these little corrosion engines has 4 essential parts. A really handy way to remember them is with the acronym ACME. You've got the anode, the cathode, the metallic pathway, and the electrolyte. If you have all 4 of those things present, you are going to get corrosion, period.
And this diagram shows us exactly how it all works together. So the anode, that's the part that actually rusts away, and it releases electrons when it does. Those electrons then travel through the metal itself, that's our metallic pathway, over to the cathode. And this whole reaction happens inside of an electrolyte, which a lot of the time is just plain old water.
So, here is the most crucial point. The entire system is actually kind of fragile. It needs all 4 of those parts to work. If you can take away just one of them, get rid of the anode, or the cathode, or the metallic pathway, or the electrolyte, the circuit breaks, and the entire corrosion process just grinds to a dead stop.
And that vulnerability, that's exactly what we exploit. This right here, this brings us to the real aha moment. How do our engineered shields, our coatings, actually stop this incredibly powerful natural force? They do it by forming a barrier,
It's so elegantly simple when you think about it. A coating physically separates the steel from the environment around it. And by creating this simple barrier, the coating is actually dismantling that whole electrochemical cell we were just talking about.
So let's look at exactly how it does that. By just preventing water, remember that's our electrolyte, from ever reaching the metal surface, the coating literally removes a key component of that corrosion cell. No electrolyte, no circuit. No circuit, no corrosion. It is that direct. The shield works by breaking the engine of rust.
But here's the thing. The science is only half the battle. An engineered shield is completely useless if it's not put together correctly. And this is where the human element becomes absolutely critical. We need what you might call guardians of the surface.
There's a saying in the industry that just perfectly captures this mindset. You get what you inspect, not what you expect. You can't just cross your fingers and hope a coating was applied correctly. You have to verify it. Every single step, every single layer.
And this verification, that's the job of a coating inspector. Now, they're not the boss on the job site. They're a highly trained quality technician. Their one and only focus is to observe, test, and then report on whether the coating application conforms to the engineering specification.
And it's really important to see how they fit into the bigger team. You've got the specifier, that's the person who designs the system. You have the contractor who actually builds or installs it, and then you have the inspector who acts as that independent quality check, making sure that what the contractor built actually matches the specifier's design. Each role is totally distinct and totally vital.
And their work is incredibly systematic. It's not random. They plan by reviewing all the project documents. They assess and test literally everything from the weather conditions to the thickness of the coating film. They verify that every result meets the standards. And, this is crucial, they document everything, creating a complete and permanent record of quality control.
So, from the fundamental science of a tiny electrochemical cell, all the way to the diligent, systematic work of a coating inspector, this entire unseen industry is working around the clock just to ensure our world doesn't simply rust away. And that leaves me with one final question for you to think about. What unseen shields are protecting you right now?